Okay, thanks. So, ladies and gentlemen, can we start? Just probably a few seconds, but I think that almost all the people that intend to attend this session are here. So, welcome here. This is the last session of the day, and you are in a Key Technology for Future Competitiveness session. Welcome. My name is Marco Falsetti. I have the pleasure to moderate this session. We will have a speaker, clearly, for discussing about that. Just a brief introduction to the session itself. When we discuss within the advisory board of the conference about this section, and we address the idea of key technologies, the main problems was, okay, what should be the key technologies that we should select to bring on the stage of this session? And it was a difficult answer because it was almost impossible to say if what was most relevant of other. So we just try to pick up some example, and we have asked our speaker, and we choose the speaker to try to follow main area of technologies, starting from the area of digital. We will go in deep in some cyber aspect, energy with area of photovoltaic, and we have in any case a speaker from Commission that is not driven by technology itself, by some kind of political analysis behind that, and we have also some speakers that will arise about the chemical aspect and technologies with some example quite close to the circularity. So what we'll do is that we will present and we'll give the floor to the four speakers for a first round of presentation, and they will go here to present their own slides. And after that, we will try to have time to discuss about some transversal aspect of the two keywords of this session that remain: technologies and competitiveness. And I also want to invite you to participate to the discussion, in particular during the second part of our session, when we will give the floor to you, but please feel free to refer to Slido and to put your statements or your question already during the first phase. In any case, we will went back to that part, and we are going to address all your questions during the second part of the session. So, I had the pleasure, I will start to ask in the order that they will present Doris Schrecker. She is head of UNDG Research and Innovation. Please, Doris, if you want to join us. And she's come from the European Commission, is in charge of industrial research, innovation, and investment agenda. But for people who are in the business of industrial technologies, knows quite well Doris, because there are so many years that you are around in industrial technologies that each of us know you quite well. The second one is Bruno Scharat from CA. So we are one of our important person that have hosted this meeting. Bruno is deputy of the director of CEA Technological Research Division. He has a long experience, more than 20 years in digital, and he comes from industry. He joined CEA not so far. It was around 2012. So yes, 2012. At present, he's acted also as as head of the CEA cybersecurity program, and clearly has a lot of roles in many different committees at French level, European level. Now, Maurizio, but we can skip, not in the order, Mathilde Berger, sorry, you are French, not German. You are working in Germany, but yes, thanks a lot. From Haska. So she has a university background in chemistry and physics, so she's relatively young. So the curriculum is totally still to be written, but I'm sure that you will reach your curriculum in the next coming time. So Maurizio, you will not be the last, but you will be the third one. Maurizio Crippa, PhD in material science, many years dedicated in academia, investing in organic and inorganic chemistry, but you are here as a co-founder of GR3N. No, you don't worry. The first will be Doris. You will be the
why are you calling? Oh, sorry.
No, I told you will be the third, not the first, sorry. But you are here as a co-founder of GR3N, so that means that you will tell us about your experience in this area. The company is a chemical recycling company, so we will go in deep after that. So now, let's start from Doris again. You will not report a totally technological presentation, but you will, please come here. You can use mine or you can use one of the other. Don't worry. Okay, perfect. And this is the flow when you have. This is your controller. Okay, Doris. Technologies, key technologies, European Commission. Probably we have years of discussion about that. And can you just introduce what was the last exercise that in your unit you did and how this can be helpful in setting the scene for the political background of political research policies behind this part? This will be quite nice. And after that, we are going to deep explore better.
Thank you. No, I think I have everything. Thank you very much for this very nice introduction, Marco. Thank you for having me here. I have come with a portfolio of technologies, but packaged in something which we called technology roadmaps. And I'm sure that you're all familiar with roadmaps and technology and research and innovation roadmaps. So I am very happy to explain to you what this is that we call a new policy instrument. And I have come with pleasure because the title of our session is also Key Technologies for Future Society and Competitiveness. And the technologies I'm bringing, they have a purpose, and you will hear about that. So I start with the rationale. You know about the European paradoxon. We are super in research in a nutshell, but we are less super in exploiting the research and doing business with it. That is in particular important in areas where we want to achieve certain goals, like the green transition or the digital transition. That is something where things are time critical as well. And this is where we would like to see. And you have probably read about the commitments about competitiveness as well. We would like to see what tools, what instruments do we have to accelerate the uptake of technologies and R&I results in the economy. And this is what the new European research area has as one of its pillars, how to accelerate the take-up and the deployment of research and innovation results. And this is mirrored as well in the new industrial strategy, which is actually at heart an innovation strategy. And you find a lot of references to the basis built in research and innovation. And the technology roadmaps, which we have created to bridge these two, sometimes worlds, the R&I world and the industrial worlds, that is what these roadmaps are about. So I mentioned in the beginning that it's also about the future of our society. So I make it very big and I say this is about research and innovation to address planetary challenges and to work on solutions. We have at the moment started the work on 2 European research area industrial technology roadmaps, and one is to support the quest of the European Union for climate neutrality 2050. where you see, where we have, you know that as well in the industrial technologies, we have a partnership for energy-intensive industries, we have a partnership on clean steel. These are industries which are important at the moment as producers of emissions, but at the same time we hope that we can, that they also provide solutions. So we look into what can we do to help them play their role for the emission reduction objectives 2030 and climate neutrality. And that goes beyond what we do with the partnerships. We build on the partnerships, but then we look into what does it need to really deploy the solutions. The second is the circular economy, the second big pillar of the European Green Deal, where also there are many sectors which produce a lot of waste, which are pollutant as well, or more pollutant than we would wish for. And you saw the Commission issue a lot of sustainability strategies for the chemical sector, for the textile sector, the zero pollution strategy. And we are looking into that to say, okay, if we invest in R&I, or if we know that certain technologies are key to get, for example, circularity going, what are these technologies, what are the industries which need to deploy them? And before that, also develop them. So it is about the R&I prioritization and then moving over to deployment. So we have already completed the first of these technology roadmaps, which was a pioneering work. It was a bit experimental, but we could build on a lot of sources and resources, and it was on low carbon industrial technologies for energy intensive industries. We published that report on the 8th of April. You can read it. We would be happy if you read it and find it interesting, because we start already to go into the next step and to look into how can we implement it. We are at the moment developing the second roadmap on circular industrial technologies, where we are also working for both roadmaps with the member states in the European research area, with industry through the partnerships, through workshops with the research community. And you can expect very soon also a consultation on that, where we hope to get a lot of feedback. So this is what we have at the moment. You see as well that we build on what the partnerships have already developed in terms of strategies and research and innovation agendas. And we would like to go that step forward to say, and what does it need? How can we really get that into onto the market? So this is again back to the low carbon technologies roadmap and the energy intensive industries. It is our first example for such roadmap, and it builds on evidence. So we are looking a little bit back and where we are now. So it's not about the research roadmap up front, but we want to know where do we stand, what are these key technologies, what do we expect from them, and which technology readiness level do they have, and where can they actually be used. We have looked at scenarios for the implementation, because other experts have already thought about that. We have looked into tools and instruments also in the member states and into the regions, where we see potential of synergies to pool resources and efforts to accelerate, because the important thing is not to wait at the moment when we have research and innovation results, but to have anticipated already what next steps we could take based on a good assessment and knowing what we are doing and what for. And we have provided then an outlook on R&I needs and on investment needs. We looked into patenting, into what the regions are doing, a bit into the regulatory framework, of course, and valorization and standardization. I give you here, and you find more of this, of course, in the roadmap itself, the package, the portfolio of technologies. We have found many sources and who converge on these different technologies, which are applicable across the different sectors. We looked in particular as well at the potential of cross-cutting, cross-sectoral approaches in this. And we looked Also, you may recognize some of these pictures. The green one is taken from the Strategic Research and Innovation Agenda from the Process of Planet Partnership, for example. We looked into scenarios and investment needs. And in a nutshell, the conclusions are that we tried really to map and to carve out the gap between what we see in terms of current R&I investments. That is not only the framework program, but also what we could identify in terms of industry investments and member states, and what we need to reach the Green Deal goals. That is for 2030 and for 2050. With the need to really provide for the investments into the large-scale demonstrators and first-of-a-kind installations. And you see that here, for example, we said, okay, we see potential for continuing to work together. We see potential for an industrial alliance or something similar. There have been discussions. They have not yet materialized. Maybe this roadmap provides new food for such considerations. We also look now into the question of permits. We heard about that already at this conference. It's also in other areas an issue. It seems to be an issue also here for these first-of-a-kind installations in the energy-intensive industries. We are looking how to establish a community of practice, how to analyze what is needed, not to need to wait for these permits and to find a framework for this. And then you see as well that we try to move on with standards, and we look also into the potential of IP. We will apply, or we are applying, a similar approach for the roadmap on circular industrial technologies. Here you see a kind of outline of the type of technologies and the groups of technologies which we are looking at. You will find more detail than in our consultation. And also here, we will look at scenarios, we will look at investments, what we see and what we see needed. And also here, we will try to identify what could be the very practical next steps while we are still investing in research and innovation in Horizon Europe, for example. And you see here that we keep our link to the European Research Area Policy Agenda. We will continue to work with the member states. We are just waiting for feedback on what we call the Action 12, which is a dedicated action with different elements like technology infrastructures or these technology roadmaps, how to accelerate, exactly what I said in the beginning, how to accelerate the deployment of research and innovation results. And this first technology roadmap will feed into the industrial transition pathway for the energy-intensive industries, and we would like to do similar things, for example, with the circularity roadmaps in the ecosystems which we address there, textiles, construction, and also, again, the energy-intensive industries. So I close here also with my appeal to you in the research community and in the industrial community. This doesn't work without you, and actually it's done for you. So also the feedback will be very, very important. You see here again the next steps we plan to do on the low carbon roadmap, the industrial transition pathways, an implementation plan, the second ERA roadmap. We want to expand our perspective on what we can support through the framework program as well into what happens afterwards. So it's R&I policy beyond the framework program and a very practical link to the industrial strategy, and not the least to you and your business world and your business cases. So here, I list here some needs and opportunities for industry engagement, and I would hope very much that you find it interesting and that maybe some things come back afterwards in the discussion after the other speakers here as well. Thank you.
Thank you, Doris. Yes, please. Okay, a lot of provocation because you cover a broad range of different technologies, so I'm going to yes, otherwise I mix up with your paper. And thanks a lot. We are going to certainly comment in a broad way all what you say. Just a comment, because you publish on the 8th of April. What happened recently with the Ukrainian crisis that will affect a lot our policies? Did you have any effect in the roadmap final definition?
What you will see is we had a last-minute insert on the energy and gas crisis. And then we tried to publish as quickly as possible, honestly. And we feel actually that the discussions around the impact of the war in the Ukraine, the gas and the energy issues, the crisis situation at the moment, is actually supporting that we need something. So we are really wondering what can we, and I think the time pressure has even become more urgent.
Thanks. Okay, Bruno, now the floor is yours. Again, we start from a broad discussion of technologies because SEA has a large spectrum of interest, but you will focus probably on specific cyber security after that. The floor is yours.
Hello to everybody, and I'm very happy to be with you today. So I'm going to give you a quick overview about what CA is doing. And in French, CA is a name from the Atomic and Alternative Energy Commission, and that the largest RTO in France with around 20,000 employees and a budget of 5 billion euros. And CA is working on a very few specific and strategic areas like defense and security, where we have to develop and support the Ministry of Army in France for some key action. We're working on low carbon energies, and Doris just emphasized the importance of having technologies done in this field. We are working on fundamental research, and in particular, we are very part of the climate change process, JEC. And we are working on technological research. So I'm part of the technological research division, and our job in CA is to improve the competitiveness of French industry by developing technological and bringing skills and transferring to the industry. And it's quite clear that we're working on a few subjects that Europe is facing in terms of challenge. The first one, of course, is digital transition, where we need to be able to use digital to improve the overall efficiency of processes and a few actions. And it requires to be able to get some trustworthy product and services, to be able to design and manufacture efficiently product. And to do that, you need to have a few enabling technology like microelectronics, like artificial intelligence, like quantum, like connectivities, simulation and computing. Doris just emphasized the importance to move from a high carbon world to a low carbon world, and CA is working on subjects like nuclear and renewable energy and clean hydrogen. Of course, due to the demographic conditions, there's a lot of challenge regarding to the fact that we need to work on optimized healthcare systems, and we're working on medtech, and on the circular energy, we're working on raw material saving and recycling. And a lot of work regarding defense and security, because clearly it's one of the new and very important challenges, which are both cybersecurity and both privacy. You have to be aware that, that the cyber threat is quite a new subject. If you remember, in 2007, when the director of the National Intelligence Agency in the US, John Negroponte, published his report of the threat worldwide, he did not use the word cyber. Now it's quite clear that cyber is a big problem, and if you look at the latest EXA report regarding the major risks for industrial companies, worldwide, cyber is number 2, and in the US it's even number 1. And that's brand new. And if you, in Europe, it's just after climate change, but it's seen as more important in terms of risk of instability. And that's pretty normal, because when you realize the digital transition that we are experiencing in most of the industrial companies, you have to be aware that digital transition is an Eldorado for evil person. That's what Guillaume Poupard, the managing director of the French cybersecurity agency, the NC, said when he opened an initiative in Grenoble. And when you think about cyber threat, you might be aware of some which are not very dramatic, which is activism, and in particular digital activism, where people are using internet to deface internet website or to promote their language. Of course, the most common is cybercrime that every one of you have heard about, because ransomware, because of the fact that some factories has been shut down, that there have been a big ransom. But it can be even worse. And for industrial company, the biggest and the most malicious form of cyber threat is spying. That's great to develop new products, that's great to develop new technologies, but if your competitors are able to steal them from you in a very easy way, it's a disaster for your companies. And spying is a real subject. We do not speak a lot about it because it's less mediatic than a ransomware and this kind of extortion process. But you have to be aware that there is a very strong intelligence and a counterfeit organization, and that's a big risk. And then the latest conflicts between Russia and Ukraine showed how now the digital translation can help some operation like destabilization and like sabotage. And again, it's not common for industrial company by chance. There have been some which have been suffered by collateral effects like WannaCry or NotPetya, but it could be a risk in the future. So when you speak about cyberspace, usually you have to take into account three main layers in cyberspace. The first one is hardware, and hardware is everything which will be able to generate data, like computers, smartphones, like servers. The second layer is software, and the third layer is data. And you need to have technologies to secure all these layers. For example, if you want to secure hardware, you need to be able to have access to security chips, like the one you have in smart cards. You need to be able to have access to trustworthy hardware to ensure that there is no intelligence, no spywares which are put into your servers and that will be able to retrieve information from you. And you need to be ensured that, and you need to have access to hardware security assessment tools to ensure that the level of security is correct. That's a great subject within Europe currently, and there is a cybersecurity package which has been set up by the European Commission to ensure that the level of hardware is going to increase, and even basic product will have some security features. The second type of technologies you need regarding cybersecurity is to be able to secure the software side. And for that, you need security components, usually powered by artificial intelligence, and you need software assessment tools to ensure that there is no vulnerability inside your software components, and people will not be able to bring them down. And finally, to secure the data, which are presumably the most important information you have in your organization, because the data can be your manufacturing data, it can be the way you're manufacturing your product, or the feedback of your customers. You need to be able to have access to a lot of cyber security tools like supervision, like cyber threat, and you need to be able to have access to a few new technologies like blockchain and crypto computing. All of that is critical, and we need to be able to have some sovereignty in Europe for this kind of tools. And that's the reason why you find the key enabling techs which are behind this kind of tools. Of course, microelectronics, and you see how the European Commission is currently working on the EU plan on chips to ensure that we are building some sovereignty on the chip manufacturing side. Of course, there is the quantum tech and all the work regarding open hardware. Of course, cryptography, because due to the fact that in the near future there might be some quantum or computers, some of the current cryptography might be useless because it will be easy to break, and we need to be able to bring some the next generation cryptography. And finally, we need to be quite strong on a few technologies which are artificial intelligence, digital twin, and blockchains. So again, Europe is quite strong on all this, but it's very important to take into account the fact that these technologies are extremely critical for cybersecurity. And when you think about the competitiveness of your companies, when you think about your competitiveness of your labs, take into account that you need to secure your cyberspace. So just to do a final conclusion, if you could have some thoughts out of this presentation, first, do not take cyber threat as a low impact on your business. cyber threat is here. It's costing a few thousand billions of euros for every companies in the world, and it will impact your competitiveness. If you're doing product, if you're doing operation, if you're doing manufacturing, try to eradicate your vulnerabilities and try to secure your product at minimum. Again, there are going to be a cybersecurity package which is promoted by the European Commission, and you will have some incentive to make it more and more robust, but take into account that it will be soon a mandatory things. But even if you're securing by design your products, be aware that the attackers are more and more harmed, and something which is secure now might not be secure in the near future. That's the reason why you need to think about resilience and the fact that in the coming months, maybe an attacker will be able to break into your system, and you need to detect that. If I had to take an example, if you're building a safe, even if you have set up the best safe that you can imagine, you should put some sensor in it to ensure that if somebody is able to break in, that you'll be aware of that. And finally, two last recommendations. Train into your staff. It's extremely important that you realize that your staff is the first people which are confronted to cyber threat, and depending on their level of education, the level of tools they have access, it might be extremely difficult to resist to that. And finally, try to join ecosystem, because cybersecurity is cooperative and collaborative. You might try to do everything you're doing alone, but it's much more important to collaborate, and Europe has set up a lot of very interesting ecosystems, like the Sparta ecosystem that CA is part of, or more recently all the European digital innovation hubs, where cybersecurity is often a very strong subject in it. And you need to see whether you can join or not, and what you can retrieve from this information. Thank you for your attention.
Thank you, Bruno. I was just wondering if I had to be much more preoccupied or to be relaxed for the quantity of technologies that you can have in your pocket for counteract cyber security problems, because in any case, it's a big mess in this moment to deal with.
For cybersecurity, the main technologies which will bring some helps to the people trying to resist to attacks are clearly technologies like cryptography and post-quantum cryptography in the near future, and artificial intelligence, because due to the fact that the number of data is going to be enormous, and usually people are thinking about data as the oil of next century. But one of my colleagues, Michael Iponen from FCQ, is using the image that data is not oil, but data is uranium. And once you have this image in mind, you realize how it's going to be extremely difficult to manage this data, and you need to be able to cope with the complexity. So everything that will help the automation about the way to resist will probably be a strong help.
Okay, thank you. Now we jump to a completely different, Maurizio, circularity, polymers. So can you give the best of your potential technologies in the future in this field, quite relevant for a lot of different reasons? Thanks.
I will try. Good afternoon to everyone, and thank you for inviting me here, Marco. Plastics. This is what we have in our minds. Before the pandemic, these were the pictures that I was obliged to watch every day. Then the pandemic arrives, and this problem was a little bit on the second priority. But it's still there, this problem. Plastic in general, pollution, pervasive material around us. But there is a lot of awareness about this problem. Consumers, newspaper, and so on. But there was a little paper which was published in 2019, A Circular Economy for Plastics, from the European Commission. I was part of this group of 11 experts to tackle the problem of plastics. Before everything, before seeing the images and the pictures, the European Commission started to think about this problem and starting to prepare the future for this. Because the problem is huge. Here you see that 60 million tons of polyester are produced globally for textile. Then there is another 30 million tons used for packaging. So the problem of the packaging we have in front of our eyes is the lower problem. The main problem is our clothes, the carpet we are working on, or the textile we are sitting now. This is all polyester. And this polyester has no destination. We cannot recycle. But I will elaborate with some more detailed number later about this. It's exactly here. When we have 80 million tons of monomer production every year to produce virgin PET. But look at there. If you see the arrow, only the arrow of, then 1/3 is to use for packaging and 2/3 for textile. But if we see the recycling is only on the packaging side. Of course, because if you take a plastic bottle, which is colorless or not colored, you can use to produce something else. For few fraction, you can use to produce a new bottle. But for the main part of these plastics, you use to produce textile. For example, the belt, the seat belt of our cars are black. Why? Because they contain mixed plastics from bottles with carbon black. So the black covers everything. But the point is that after that, they become a textile, and they become a textile. And what's the end of life of this textile? Only one. Incineration or thermal recovery or landfill. Incredibly, in all the statistics we find, there is a 19 million tons of use and reuse of textile. Yes, it means that the t-shirt we do not use once, but we keep in our closet for some time. And this is calculated as use and reuse. But it's fake. It's just postponing some years where the material is at the end burned. But with chemical recycling, intercepting the material before end of life, we could really do this. We could take the material destined for landfill or incineration and go back to the building blocks, to the monomer, to produce virgin PET. This is our dream, of course. We are not the only one. Green is not the only company doing this. There are other companies in Europe. And Europe is driving this kind of technologies. So we have a very important role as a driver, as a continent. We do this with a process which is circular itself. I would like to bring your attention about the dark in the middle where it's green. As you can see, our byproduct of the reaction is table salt, sodium chloride. But applying electrolysis, we recycle the sodium and the chloride to produce the chemicals we need for the reaction. So our process is completely circular itself, not only enabling circularity for plastics, but also circular itself. Of course, we are energy dependent, but the quality of the energy you provide to the plant gives different level of sustainability. If we apply energy with the mixed European energy, in Europe, the Eurostat provides all these informations, but if we apply the mixed energy in our plant of Europe, we have minus 60% of energy involved to produce monomer compared the energy to produce from oil. So it's a huge saving. Again, I want to put really the attention on the role of the legislator. In this case, in order to help to develop the technology, we started a long time ago, because you have to be resilient when you do chemistry, and we received 2 European projects. The first one was seen by Optima, giving us the possibility to realize our first pilot reactor, and the second was Demeto, which is now finished, which gave us the possibility to realize a demo plant, which is now commissioned in the center of Italy. Again, without the support for R&D of the European Commission, we could never arrive to this point. This is very important for us. Just some insight of our process. We take 10 minutes to depolymerize the polyester, and we are very tolerant against the contaminants. Typically, we put a threshold on 30% contaminant, so we can process 70% PET and 30% no PET. Whatever it is, cotton, polyurethanes, titanium dioxide, carbon black, blah, 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 everything. And as I said, minus 60% of energy involved. Compare the energy to produce the same monomer from oil. Those are some examples of material we have treated. We have processed, you can see, are from packaging or to textile, colors, no colors. We do everything. The point is that the product of the process has to be in spec with the product of oil. Otherwise, we don't do upcycling. We keep going doing downcycling. So our goal is to bring up on the functionality of the material, not equal or down functionality, but up. Textile, carpets, bottle. Thank you very much for your attention.
Thank you, Maurizio. Okay, a lot of provocation because it seems a sort of final solution in principle. So we will. What should be at least to your consideration, estimation? What is a realistic timeline when this kind of technology could be really play a role in the recycling of polymers?
Yeah, we are now doing the basic engineering for the industrial plant. That will be, cross your finger, real commission on 25. So this is the plan. We are talking about chemical plants. It takes 1 year to do the basic engineering, 1 year to do the feed engineering, then you have the EPC, which is 24 months. And I am an impatient person. So I always ask can we go faster? But the engineers, they block me all the time. Say, no, we need our time. Fine, I have to wait.
Okay, it will be not too far away in principle, so it's a good result.
I could tell the story differently. I could say that we wanted to be ready for the January 1st, 25, when the European directive obliging every member state to collect a textile, and we wanted to give the answer. But it's not true. By chance, we arrive on 25.
Okay, thanks. We will come back. Mathilde Berger from ASCA. So we change again. We have moved to the organic photovoltaic. You have a lot great solution in these fields. Can you show something, please?
Hello. So I'm Mathilde Berger from ASCA, and I'm working as project manager there. Thanks for welcoming me today for the presentation. So what we are doing at ASCA we're doing unique photovoltaic solutions. And who we are. So we are a company based in France and in Germany. And with 10 years of innovation, we have brought a new dimension to photovoltaic technology. We are then combining aesthetic designs together with the solar energy. Thanks to this, we are able to offer to our customers some completely newly designed solution to integrate solar energy into any of their products or to any of their designs without limit to their creativity. And why we are doing this? We want to maximize the use of solar energy. The traditional solar energy that we all know is usually referring to the silica solar cells that we can find in solar farms or in the rooftop. This is one usage of the photovoltaic technology. However, we want to go further, so our aim is not to replace this technology. Our aim is to enter new markets and to offer new solutions where there were not so any solutions before. So what we are doing is that we are not working with a standard product that we have on the shelf with several references, but we are always developing customized solar solutions with a lot of aesthetics and environmental friendly solution on an industrial scale for our customers. Moreover, thanks to their unique properties, the ASCA solution can be integrated into almost any surfaces, making them then energy active, meaning generating some energy. This integration is not only limited to the material, but it is also taking into account the environment. Indeed, our technologies are working with diffuse light, ambient light, meaning that here in this room, they would also produce some energy. And the second aspect, which is really interesting and important for aesthetics, is that we can adapt their shapes and play around with their design. With this combination of integration into environment, material, and the different shapes, we are able to go into new applications where it was previously almost impossible to go there with the other more traditional photovoltaic technologies. But then how can we do this? Thanks to what? So we're not working with silica solar cells, but we're working with organic photovoltaics. And here organics is referring not to nicely grown without pesticides or the likes materials, but it's referring to the branch of chemistry which includes carbon and hydrogen-based materials. In the end, how to produce an organic photovoltaic module? We are having some active polymers that we are printing as an ink on a substrate, a PET substrate. So we're working with really thin layers, allowing then us to have a really lightweight, thin, flexible, and semi-transparent material. This material are also highly sensitive to diffuse light. And that's why it would be possible, it is possible to use them for indoor application as well. But this does not limit it to indoor application. This also means, for example, that if we want to go on a shaded environment or on the facade or somewhere where you don't really have the perfect orientation to catch up the light of the sun, then the modules are still producing energy and not really affected by this lack of light. And last but not least, the modules have also a rather low environmental impact thanks to their process of fabrication. As we are printing them, we are also able to cut them to shape and to design them. So we can design the shape, the pattern, and we're also playing around with several colors. And as mentioned before, we are playing a lot also with the integration, going into and onto several materials, going from glass, plastics, polycarbonate, for example, textiles, concretes, and so on. So we can easily integrate them onto almost any surfaces. As I said, and what is also for today's call really important, we also have a really low environmental footprint. This comes from the fact that we're using organic materials, so there is no use of refined silicon or rare earth materials. The process is simply a roll-to-roll process, which is made at ambient temperature, ambient atmosphere, and all the materials we're using are 100% recoverable. This is also highlighted by the award that we won in 2021 by the German Sustainability Award in the climate category. As we're not working with a product, but in the technologies that we are bringing into several solutions, we are working in a really wide range of application. The one where we are having most projects out of today is in the architecture, where we are combining the implementation of solar technology within the whole building with a high design and aesthetic aspect. And here, when we're talking about the whole building, as you might have understood, we're not limited to the rooftop. We can go in windows, facades, canopies, and the like. However, we're also working in other markets, such as the electronics, where today you have a lot of connected objects which can easily be powered thanks to a battery, or could be powered thanks to a solar cells on them to make them more standalone and avoid the replacement of the battery. Another field is the mobility, where here the access to the energy at the point of use is really important, because this point of usage is definitely moving. That's the definition of the mobility. So it's important to be able to produce energy directly where we need them. And the last one is art and fashion, because it goes well with fully designable and aesthetics. And as we have the possibility to work with lots of materials, then there's not a lot of limits to the creativity. So in the end, we are not in competition with the standard standard solar technology, as we are really working at producing the energy at the point of usage, and not from the business where we are having a generation of the electricity and then the usage. We try to decorrelate things. Thanks to this, we can also lower the impact on the infrastructure. We do not need to consider how to bring the energy produced at the point A to the point B where it's going to be used. And that's why for us it's more integrating the solar technologies onto projects to bring them functionality and to become part of it with additional functionalities, more than having the usual financial model where we are selling the energy and then taking it back. But as we're not competing then with the more traditional solar cells, then we still have somehow a competitor, because we are a new technology. It's always hard to enter the markets and to get to bring really this technology into projects made together with companies and with customers. However, I will show you a few of our references, especially in the architecture. So this is, for example, our biggest project that we delivered this year, which is in Basel for the Novartis Pavilion, where we have a self-powered media facade. So all the facade that you could see here with the small diamonds are in the end more than 12,000 OPV modules integrated in the facade, allowing the LED to light up and to create the facade during the day and during the night. And if we look at this picture, we can really clearly see that the OPV is then not an add-on, but it's really something part of the project, as it's completely part of the envelope, but also it's the anchor point for the LED system, which creates the media facade. Then further example, this one was the Dutch pavilion for the Dubai Expo 2022 with COVID, where the solar rooftop needed to be semi-transparent and to be completely combined with the design of the architects. So here again, we've been able to use OPV modules with the architects. Still for the expo, this was in 2015 at Milano, where this was one of our first projects where we did freeform and customized solutions. So the OPV modules are all the hexagons with the different sizes that you can see. And here it also represents well how what means the new solution and the complete design solution. We're talking about solar energy, but you can barely see any cables to conduct the energy here, because this is part of the project. We want something which looks nice, so we are trying also to hide them. And then I will go through other projects, which is here a balcony balustrade for a residential building built up in Germany. This was for a green building where the rooftop was already covered with silica panels, but the energy generation was not enough, so they needed an additional source of energy. And once you have taken the rooftop, then you only have the walls left. And that's where we decided to go into the balustrades in order to fully functionalize the balustrade and to add another assets to them. So here we're having some other glass integration or polycarbonate integration for several buildings that we did over the last year. Also with ETFE membrane, so the range of material is rather large. And some artistic sculptures. So we've really been from the smaller projects to now going to the really larger project and larger buildings application. Thank you.
Thank you, Mathilde. So, not only technology, but even beautiful solution may be a way to increase competitiveness of our industrial system. Okay, first of all, I would like to know from the colleagues if there is something in Slido. No, so we had to continue, and we had time to discuss between us. Okay, so try to have a second round, but you can stay here and just to reply. So Doris, you introduced this roadmap, and so I'm trying to be provocative, but don't take me in the right way. Okay, we got an exhaustive, even if short times, description of what is in. So you have a lot of stakeholders of the area here. So what should be the value and how we should regard this roadmap for the next steps? So what should be our role and in which way this roadmap can help us to step forward in some kind of progress?
The roadmaps are very ambitious in the way they want to speak to you in the industry, but also to the member states. So we try to find a language and a way of presenting so that it's appealing to everybody, because there's a need to work together. So we would like to have the roadmaps for information of the member states, where things stand, which they can then also bring in the discussions with their industries. I had very recently, for example, a meeting with regions, and we realized that also the regions like to have some information of where these technologies stand, because they have companies in the regions which may need to invest, or which are in front of questions, or which may or may not be engaged in researching these technologies. And the question is, where would they get information from? How does it work in practice? So we reach out to different communities here. And for the industrial community, there's, for example, also the question like, do you have a plan? How do your next 5 to 10 years look like? Are you planning investments? Are you planning these technologies? Do you need to liaise with anyone, other partners? We speak about industrial symbiosis, for example, that you liaise even with plants from other sectors. So these kind of questions, I think, are at the moment on the table. Part of them we can address already in the research and innovation activities. Part will then follow up and tries to realize. The questions and standards, for example, it takes a while until standards get into place. We can start at an earlier stage maybe, or we can help to produce the data or things like this, so that we start these discussions already while things are maturing, so that we have also like a compass for assessing the maturization and getting it forward. And in the end, it boils down to investments. And I think also here, public and private work together. And at the same time, we have certain rules. And the driving force we expect to be with the industry.
Okay. I had to say, yeah, to admit, I not yet have time to read it, but I will go through with a lot of attention, I'm sure. Bruno, we already addressed this question privately, but I want a comment from you. You are from CEA, is one of the most large organizations dealing with technology and science in Europe. And the question is related to the idea of competitiveness in a different way. You know, Europe has been for years characterized by something like openness. We were really one of the most open systems all around the world. But now, in the last years, we have changed a little, or we try to change a little. We start to speak in a different way. Yes, we still want to be open, but with a certain autonomy and to take care of some kind of European dimension of attention. So can you comment on that?
Clearly, the word you're using, open strategic autonomy, which appeared in the
Commission's length. Yeah, yes, I was.
Seems to make a lot of sense. The idea behind this word is to say that wherever you can, you try to work multilaterally, but wherever you must, you must be able to act autonomously. And if you look at the semiconductor industry, if you look at the digital industry, more generally speaking, on one hand, these technologies are extremely critical for European sovereignty, and you can see in the recent past that when you have a shortage of microelectronics chips, you have full businesses which are shut down. Currently, there is a manufacturing factories in France which is shut down due to microelectronic chips shortage. You can see also that in some cases, when you have tension, geopolitical tension between countries, it can be a good way to increase the tension by cutting the access to technologies. Remember China, which were not allowed by President Trump to buy components from US companies, and that put some of their business into big difficulties. And if you try to organize your sovereignty, the problem of digital industries is that it's extremely capex intensive. When you speak about the semiconductors factories, you're speaking of $20 billion of investment. The supply chain is extremely complex, and you have very limited amount of suppliers which are able to provide the right tooling. It's fairly well known that in Europe we have a champion like ASML, and if you want to buy other systems, they're US. So at some stage you need to find a way to do a compromise between your will to be fully autonomous and the necessity to be able to collaborate, because there is that few suppliers on critical domains that you need to be able to do that. But you need to organize your strategy, because if you're not taking that point well into account, there will be some risk.
Well, I would be curious to have a comment from you also, Doris, about open strategic autonomy. Is this an element for keeping competitiveness of our system at a certain level?
Yeah, I think you have said it very, very clearly, and we've heard it as well. We have a new terminology as well. We speak about dependencies, and I think this is where the red line is, that you say, okay, what is dependency and how deep is it? But Europe wants to preserve its openness as well, but sovereignty doesn't mean that you monopolize everything or so. Sovereignty means that you can stand for yourself, and you have your own strategy, and you go your way, and you are not subject to dependencies which can threaten your existence. I think this is what it is about, and to go into international. Hopefully in the future again, international open relations with a certain assertiveness as well about what you are and what you are standing for. And I think this is the way we go with the European Union.
Yeah, I fully agree. If you want to preserve your status. In any case, you have to take care how you approach the world that is outside. Sometimes the other words is not really friendly with our system. So, sorry, I had to, because I can't stay over there. So, move to Maurizio. Now, I would like to come back to the point of technology and competitiveness. You have shown your technologies, and on the other side, behind this technology, behind your scientific role, there is the entrepreneur or potential entrepreneur dimension. And for an entrepreneur, competitiveness is a crucial element. Can you say something about what is your experience in that? Because scientifically speaking, the message is clear. The problem will start in the laboratory or when you exit from the laboratory to become competitive and to remain competitive?
Well, for me, competitiveness passed through technology all the time. I was a scientist. I'm not anymore a scientist, so I did all the phase of the technology, and then one day I became the CEO of the company, and so I got to figure out how to talk to the investors, and so how to pitch the company. And so I figured out that also the competitiveness passed through relationship with competitors, or try to figure out how you place your technology in the economy, so in the value chain. So some choices which were took back in the day at the beginning were the good choices for the later stage, but by chance, honestly. Not everything was on purpose. But competitiveness, for sure, for me, is technology, and science. The rest is minimal. For instance, there is a question here related to, is chemical recycling suitable also for technical polymers? Yes, it is. It depends on the polymers. I have requested to do the process for nylon 6X, polycarbonate, nylon 6. So I have plenty of requests. And we have to increase technology and science to be more competitive also for these markets. But I have no time.
Thank you. I have another question, but second round, so just to follow. Matilde, so from your presentation, my first reaction is clearly, okay, great technologies, but probably it's not only technologies behind. The solution rely a lot on idea to create something that is beautiful. And now the question arises, when you enter in the area of organic photovoltaics, you will not be alone, you will have a lot of competitors. Is this way a way to be competitive? So when technologies is really mixed together with other, let me say, European solution like that, Bauhaus, it's an element, the beautifulness of our life is an element that has to be preserved, to be increased. So is this a competitive, in any case, element at the end of the games? Or how much is the two elements in your product that move to be a real competitive subject in the market, technologies or the great, beautiful solution?
Yeah, so today we don't have a lot of competitors, as it's a really new market. This will come with the time. Hopefully, it will also come with the time. It would mean that there is a lot of interest, and this technology is really getting into the market, so there's a lot more interest around it. For non-designable elements, we already have plenty of solutions which are already working really well. So that's why for us, it was important to have these design capacities and to combine it with these design capacities in order to get a real new solution where we could get into new projects where before it was not really possible to go. So they somehow have to be combined at some point.
So we had to wait the Chinese will copy you, not I think that we had to maintain. So you are the first, and that is already a good element for competition to be the first on,
so we're
on
not
the
the
line.
only one doing OPV, but designable OPV, we are the first, and it starts to grow all over the world. There's more and more companies, of course, doing this, but this is still a rather new technology. The Nobel Prize on this kind of conductive polymers was done in 2000, so it's rather new. It's still too new to be everywhere on the market, but hopefully it will grow. It will mean that the technology is really getting high on the market, and that the interest is also rising up.
Okay, so we're going to close the discussion, but still have one round of a very, very fast reaction. I would like to come back to the two keywords of this session, the remain technologies and competitiveness. And I would like to ask you, from your point of view, different point of view, we have commission, we have industries, we have a future market, and we have somebody that plays in a very interesting area where probably our culture and our solution may be characterized by to be European, but let's say key technologies and competitiveness. What is your final comment about that? What should be? What is our I will not say solution, but what is our right balance between these two elements? Technology is a way to be competitive, and the answer probably is yes. If we are European, if we are Chinese, it could be different, but we are European. But how you balance these two elements to remain competitive in the next future? And we'll start again from Doris. We follow the same rules. So.
For me, it is not a coincidence that I chose green transition and European Green Deals as an example here, and that we focus our first roadmaps on that, definitely. Because I am certainly believing, and it's my job to say that the future markets need to be sustainability markets. We are already using resources beyond the boundaries of our planet. And if we also take the just transition serious, then we need to find new solutions for doing that. And there will be increasing pressure. So I think this is where it lies. Green involves digital as well. I think that needs to go together. We need smart solutions. So I think that is the future. And cooperation. This is, I think, the mantra which we bring here.
Do you agree that in a competitive approach to the problems, we need to bring all the other actors in the games, because otherwise it will be difficult for us to be the only player that believe in these kind of elements?
Well, I think that we need to redefine competitiveness.
Okay. Yeah, sure. Okay, we change. No problem.
No, there was a question before regarding what will be the next after circular economy is in place. How we go next? So that was funny. We just started with circular economy. The point is that circular economy. Here we are. The point is, circular economy is a revolution. Yes. It's not something incremental. We are not something. Oh, let's go to nano, from micro to nano. No. This is a completely change of paradigm. I doubt that we do just in Horizon Europe. I think it's going to go for decades before it's really implemented. So if we started today and we are driver as a continent, this is a good way to be competitive globally.
First, thank you to
Sorry,
bring
I took your
my
place.
attention.
But not because you were focused on us. I didn't want to miss the question.
I didn't realize that there was a question
I was helping you.
over there. So thank you, Maurizio. So good point. In any case, you will have a second round about the same question. Bruno, come back to the two words of this section, competitiveness, or let's say technologies and competitiveness. Your final statements about that.
Well, I agree with what has been said about circular energy, which is a revolution. And to some extent, I think we're moving into an area of time where we start to understand that our world has limits. both on the resource, both on energy. And at some stage, if we want to, and plus the geopolitical is growing more and more complex, and if we want to think sustainable, we really need to take into account the prime of the future lack of energy, the prime of future lack of resource, and the more we can recycle, the better we will be able to continue manufacturing new tech. So I think we need some techs. It will be clearly important for competitiveness. In the same time, we really need to take into account the fact that we're moving into a next area where we will have much more limits, and maybe to some technologies we are living the golden age, and we will be in a less favorable situation in the next century.
Okay, thanks. You are going too fast, nevertheless. Maurizio, again, and we can keep a couple of questions because we have 2 questions for you, for your product list, but Maurizio, there is also again a comment on waste management.
There is
but
one.
Please.
There is one for me. Waste management against chemical recycling. We are not two different, we are not competitors. I recycle material which was managed by someone, which was before waste that someone managed. So someone collected these plastics, sorted, and gave to me to recycle. So waste management is not a substitution of chemical recycling or the opposite. The point is that the risk is that we think just one solution is for everything. But in the moment that we treat waste, so we recycle metals, polymers, phosphor, we saw before in the first session. So we have a lot of things to do starting from waste. So there is no one solution. But we have a complicated problem which need many solutions to be solved.
Okay, thanks. I will come to you in case. Matilde, just there was a couple, now one is disappeared, but there are 2 questions for you. One is clear. Sorry. I'm referring to the... Okay, start with that. The question is clear.
Yeah.
Who is going to manufacture? Because this is still a problem that we have a great idea, but at the end of the games, there are producers, some far...
So we are the manufacturers of the OPVs. So we have our production facilities both in France and in Germany. So we are buying the materials from the suppliers, and then we are producing the OPVs and working together with partners for the integration for the final solutions. Maybe I can go ahead with the rest of the questions.
The other question is much simpler. The idea behind it is, well, your product has been part of a original project financed by European Union, or was completely designed, invented, and a concept within your system?
OPV general, we are not the only one working with OPV. This is a solar technology which is worked on all around the world. There's a lot of R&D projects about them. There's also a few companies which are producing them. So it was not developed by ASCA, but ASCA has been working with them since many, many years now. And we are not to a final product. This can always be optimized, working with new materials, working with new processes. So today we are in an EU project in order to improve the technology, improve the products.
Okay. So we are going to finalize, but I would like to address 3 questions. You have already answered now, let's say, to Bruno and Maurizio. It's not for Doris because you are from Commission in that sense, but all of us are used with the European project. If we are in this room, if we are in this conference, maybe that we are done with that. So I would like to ask your very short comment. What is your experience on that, and how much European projects play a role, providing that they play a role in your technological experience, and at the same time is for Bruno, but is in a broad sense, not to a project, but to the role of CEF and in respect to these projects. Maurizio.
So the experience is complicated because the collaborative projects are complicated to manage, that's for sure. And I encountered a problem, a big problem, because the technology was developed in the frame of the European project. So I got one day an investor saying to me, oh, this was developed on a European project? Fine, I don't want to invest, because then later it's a mess about the IP. No, but it's not he left. So this was a problem that got to be, as an issue that got to be solved. We did, it's fine, but this was a problem. For the rest, was amazing. Without European project, I could never develop the technology, especially in a time when chemical recycling was, oh, who cares? But it takes time. They got the money.
Thanks. I think the Doris will be happy for these last words. Bruno.
Of course, I will give a much more positive feedback on the European project. In some subject, you really need to be able to have a lot of stakeholders working together, especially for cybersecurity. And the European Commission has launched 4 pilots to try to understand how people could work together on the way of educating people regarding to cybersecurity, redesigning the roadmaps for research and innovation. And CA is driving one of these pilots called Sparta, and just an insane experience. I mean, there is 14 member states part of this project. There is 44 partners, and now there is around 150 associate partners, which are joining the networks to work together. And this is extremely powerful way of working. And we really believe and expect that this ecosystem which has been generated will extend beyond the end of the founding of the project, because that's an extremely rich experience for all the members.
Okay, thanks. So my personal feelings is, I agree with Maurizio, sometimes it's difficult to find a direct link between the value of a project and the results, or the exploitation, the increase of competitiveness or the organization behind. But I had to say that at the end, if you look to the large number, all of us has a lot of we still continue to need the role of the European Commission supporting that, because at the end of the games, after so many framework programs, most of us start to work together just because there was the opportunity of the framework program. So it's a big, in any case, challenge, but is even a bigger possibility for us. So I don't know if you want to close with a final remark on that, and we are going to close now.
You know, I thank you for this experience as well. I think this is also what we want. And coming back to why I'm here also, it's nice to hear also on our side that it's not only about what we want to do in research, but that we can say we did it already and now we are ready for the next step, and that is to put things into reality.
That's true. That's why I mentioned from the 5th. It was my first framework program, but I was in commission at the times. So thanks a lot for your attention. Thanks to our speakers that are provided interesting elements of discussion. So I have not received any special information about logistics, as usually Bertrand done anytime. So, but this is the last session for the day, but this is not the end of the day here in the village, so there will be other activities. So the invitation is to stay in an InTech conference again for today up to the dinner, if I'm not wrong. So thanks again for your attention, and thanks again for the speakers, and we will be around in any case for another couple of hours probably. Thanks a lot.